When we make our game, of course we want something to be shown when we press play. I'm a big fan of doing as much as I can in code. So to get started, we'll attach a script to the game node. It asks us to save it immediately, and it even fills in the name of the node already. So for now we can just click create. It will switch the view to scripts, as you can see in the top of the screen. And I personally like to space everything out using tabs and keep everything lined out and clear and readable. We can set the class name of the script, which I'll come back to in the future. There are a few basic functions for handling the game loop aspect, starting with the init function, which gets called when our game node gets created. When we leave a function empty, it gives a warning and we can use the pass keyword to prevent this. It means do nothing, but it won't end the function like the return keyword. Following this is the ready function, which gets called as soon as the node is loaded into the scene. While the game is active, the function process repeatedly gets called, the delta argument, for the amount of time between the last time this process was called and this time this process is called. I like to make it clear with the leading A that the variable is an argument and to typecast it so the autocomplete of Godot does a better job at suggesting possible uses. The second function that gets called repeatedly is the physics process, again with a delta, but this function is mainly used for physics calculations. The difference between those two is that the first one is called as much as possible, while the physics one is called as steady as possible. So the first one is linked to the FPS of the game, and the second is called preferably a fixed amount for a smooth physics. To create your own function, you can just start a line with func, followed by the name you want. In GDScript, there are no private or public functions, but it's common to use an underscore for a private function. To give a type to the return, you can just add it right after like this. Let's add a sphere. To add a sphere from code, you need a mesh instance and a mesh. In this case, a sphere mesh. The radius is set in the sphere mesh and the height is set to 2 times the radius. To be able to see the mesh needs to be added to the scene, for which we'll use an addPlanet function. And the most important part of this function is calling the createMesh function we just made and adding it as a child. Then we'll call it from the init function so the planet is created at the start of the project. When we click play, however, we're still greeted by an empty screen, because the scene doesn't contain a camera, so a sphere is created in the world, but there's no way to see it. So let's first create a camera variable, and using a similar add function, we'll create the camera and add it to the scene. Let's set the position using a vector default direction backwards times 20, because the radius of the planet is already 5, and to be able to see it, you want to be at least a bit away. So when we press play, we can finally look inside of the world. It looks a bit different than the view we have when we switch to the 3D editor. But also if you add a mesh instance with a sphere mesh and the same radius and height by using the 3D editor, it will have the same gray look. So to fix this, we have to add an environment. To make it easy, we can just use the environment as it looks in the 3D editor by using these 3 dots and clicking Add Environment to Scene. It adds it under the game node, and when we click play now, our game already looks much better.